What's going on, guys? This is the trying to start to lose track. My probably third. Yeah, this will be the third installment of our MATLAB tutorials. This is our vector and matrix calculations continued. This video is you saw the last video of the introduction to our matrix and vector commands, just commands, but overall syntax, things like that. We're going to dwell into it a little bit more. So I have some definitions up on the screen, but and then some examples we're going to do later. But right now, I don't like to just tell you how to do something. I like to show you. So I've created just two example matrices, matrix A and matrix B, and they are both 2 by 2 matrices. If you watched the last video, you'll know how to read this and how this read on MATLAB converts over to like what it actually is. But just to show you, okay, this is matrix A. We have row 1, 1, 2, row 2, 3, 4. This is a 2 by 2, meaning it has 2 rows, 2 columns. And same with B. We see row 1, row 2. So we're just going to go into some basic arithmetic, and we're going to show you how to do each. Now for the first couple, it's going to seem a little elementary to add. Now this is matrix, or this is element by element addition. Well, we're just going to do A plus B, and as we can see, it takes each element. So row 1 column 1 element plus row 1 column 1 element from B, and we get 4. Likewise for row 2 column, or yeah, row 2 row 1 column 2. There we go. Long day. Same goes for row 2 column 1 elements added together. 2 is 4, 6, and so on and so on. 3, 1, 4. 4, 2 is 6. So there we end up with a 2 by 2 matrix from our A plus B matrix. And so that's how you add in MATLAB. How you would subtract is just the same, A minus B. Run it, and it's again element by element. So that is A minus B. Also, one thing to touch on, you might notice it says dimensions must agree for all this. I'm unaware if you guys have taken any linear algebra classes or anything like that to really get a solid foundation for your matrices knowledge. But if we wanted to add any like add, subtract, multiply, or divide any two matrices, they need to have the same dimension. That's why I touched upon the fact that they're both 2 by 2s. So if I were to take this one down to like a 2 by 1, I could do A minus. No, it actually might not be a 2 by 1. Yeah, we'll see. Dimensions are not consistent, so we see that is not. We can't do that. So that is what we need to do. We need to make sure our dimensions are agree with one another. So I showed off addition, subtraction. This is A minus B. Now here's where things get a little different. So if we want to do element by element multiplication, I have to be very clear with that. The fact that it's element by element. So if I wanted to do A times B, it's not A times B. We'll get into that later, but what that one actually is. But if we wanted to do A times B element by element multiplication, it would be A dot times B. And so if we run that, we get an element by element multiplication, meaning 1 times 3, 2 times 4, 3 times 1, 4 times 2. Same type of deal that we'd had with the addition and subtraction, but this time it is element by element multiplication. So the tricky part is remember this dot because you will end up with a different answer if you just do A times B. That is a different type of multiplication, and it is not element by element. So be aware of that. Now now to divide, it's kind of a similar setup. If we want to do element by element, A dot divide, not A divide, that's different. So we want to do that. A dot divide would be how you divide, do element by element division of matrices in MATLAB. So that is how you do that. And again, with those two, the dimensions must agree. And now how to do element by element exponents, we would do A dot, so say we wanted to raise a to the second power, or each element in a to the second power. We can't do a squared because this actually means a matrix A times matrix A, which we'll see is different. But if we do a dot squared, we can actually raise each element to the power of 2. So we have 1 squared, 2 squared, 3 squared, 4 squared. So that is how you do element by element exponents. So that's just kind of like the basic arithmetic methods in MATLAB, some of the differences. Some of it's a little counterintuitive, so I wanted to go over it as far as multiplication, division, and exponents. So just in case you wanted to do elemental instead of actual, that is how you differentiate between the two with that dot in front or beforehand. So that is how you would do it. Now, so this definition kind of comes into play. You'll see it better. I can explain it, but it's better seen in this definition. So if we want to say we want to look at the first row, or we'll say the first column for this example. We want to look at the first column in A. So if we look at A, it's 1, 2, 3, 4. Say we just wanted to see 1, 3. We only cared about that part of our matrix. So what we would do is we would type in A, which is our matrix that we want to look at. And so this is the part where that colon comes into play. The colon says we want all of the elements. So if we want to see every row that's in column 1, we have to denote it as the colon. That colon means to look at every row in this case, but it just means all. It just means all. So A, every row, and we'll look at the first column, and we should expect to see 1, 3, and we do. So that is how that's their colon function. It means all of the elements, and this is how you would just look at a single column of a matrix, also denoted or sometimes called a column vector. So that's how you would do that. Now for a row vector, we would want to do, let's see, we'll look at A again, just not to confuse. We'll see what A is. We'll see 1, 2, 3, 4. So let's look at the second row. Second row being 3, 4. To see the second row, we would say we want the second row, and we want to see all of the second row because we want to see 3 and 4, not just 4. So we want to see the second row, and so we would run that, and we see 3, 4. And now I can show you if we just wanted 4. I think that's what it is. I think 4 is 4 the last one, so it would be 2, I believe. Yeah, there we go. Yeah, that's how you would see 4, because you see A. If we wanted row 2, column 2 element, there we have it. There's 4. So that's just how you can incorporate both of these methods to then look at one specific element, not just a whole column or row vector. Now to look at, we want to transpose. Again, this is some terminology that would be better explained through linear algebra, but one thing that we can do in MATLAB is use this notation to take a transpose, i.e. just reverse the columns and rows. So if we want to look at A and we want to switch its columns with its rows, we can do dot and then put our quote, single quote, and we now see that our first row is now our first column, and our second row is now our second column. Now that definition is more so just like linear algebra, but the main point is just say that this is how you transpose, with a dot, a single quote. So that is how you would do that in MATLAB. And a conjugate transpose, how you would do that is without the dot, so it would just be with the single quote is how you do a conjugate transpose. Now the thing with a conjugate transpose is I can make a matrix to better show what it actually is, but if you don't know what a conjugate is, then you probably won't know what a conjugate transpose is, but I can do my best to try and explain to you what a conjugate transpose is. But basically it is a transpose, but it also takes the conjugate of that transpose. So One way to do that is just with the single quote. So we want to take the conjugate transpose of C. We define C, and then we do C with the single quote, and we see the conjugate transpose of that. And so in doing so, we have not just the transpose, but we also have the complex conjugate of our elements, being that 8 plus 5i, 3 plus 2i, and 3i. So we can see one row now turns into one column, and that is how you take the conjugate transpose. And so now, before when I was referring to the difference between dot multiply and multiply, the difference being there's a, actually it's called it's usually row by column it's row by column. This video isn't to teach you how to do matrix multiplication, but if that's something that you don't know how to do and would like to learn, I'll show you. You've seen matrix A, you've seen matrix B, so I'll show you the solution. You can do some research and some learning and figure it out and try for yourself and see if you get it. But to do matrix multiplication, not element by element, basically what it means is this is like the standard form of multiplication you would see with matrices. You don't see too much of element by element multiplication. So we would do the A times B, and we end up with a 2 by 2 matrix. That's the other thing. With matrix multiplications, we need, let me just show you. So with matrix multiplication, oh no, I've already defined A. I think I've already defined, I don't think I've defined a C, so I'll do, let me see if I can do this. So if I do, yeah, C, yeah, so we also, as previous where I stated that the dimensions must agree, the same is also for this matrix multiplication. You can't do a 1 by 1. Well, not sure why that's in there. Let me correct me. Yeah, so we need we need a square matrix. And we need the correct matrix to do this. Not just square. That's wrong wording. We need, I'm kind of conflicted between teaching linear algebra in this episode, but I'll scratch that. Hopefully you guys can go, and you already have the background. Hopefully I'm not confusing you too much. But for matrix multiplication, it's A times B, and we would run it. So forget what I said earlier about the dimensions. There's different rules for it, and I would not. I'm not in the position to teach someone linear algebra. So I think that's something that should be done on your own, and then come back to this video and you'll understand it a little bit better, if you don't already know. As we've been doing these examples, I've kind of been doing some of these ones that I've already stated down here. So we created two different vectors of the same length and add them. So those are A and B, and we've done that. We've subtracted them, element by element multiplication before element by element division, raised 1 to the second power. This is one that we haven't done yet, so we will create a 3 by 3 matrix and display the first row and the second column on the screen. So let's just take our knowledge from the first video. Let's make matrix D, which is going to be a 3 by 3 matrix. And just show you, I will just, I gotta run it. There we go. So here we have matrix D. We can see it's a 3 by 3 matrix, and so it's that. So we want to display the first row and the second column on the screen. So we can do, there's a couple ways to do this. If I just want to see, if I want to see the second column, we'll do the first row. So we see, want the first row, and we also want the second column. So we should see 2, 3, 4, and then second column would be 3, 5, 8. Okay, 2, 3, 4, 3, 5, 8. Yeah, no, that's how you look at the first. So that's the first row. So I'll just first. That's an at. I don't want that. First row, and we have second column. Oh, that's an at again. Oh, okay. Yeah, so that's how you would do each of these, and then you can play around with them too. You can either even look at, oh, what's the element that's in the first row of the second column, run that, and we see that that's 3. Second row, second element, that's 5, and if I did 3, 2, it will be 8, please. Yeah, there we go. Okay, so hopefully that helps you out, seeing what you can do in MATLAB. Makes working with matrix manipulation a little bit easier, and hopefully in the future it'll make your life a little bit easier. That's the purpose of this. So good luck, and I will see you in the next video.